Okay, I think we're now recording. Super. So for the purposes of the recording, it's the 27th of January, and this is a webinar with a lovely group of incredible coaches from around the world. And we are covering a whiz through the introduction to some of the climate and ecological science. Now, I know that there's a whole load of wisdom on the call, so I would really like people to offer up other stuff that you know that is maybe I don't cover, and certainly please put questions in the chat or you know, come in with questions. This is less a slick corporate presentation and more me speaking from the heart. So right, I will screen share. What I would say also is that, as I said before, we're not really going to get into what we're going to do about it because we're having those conversations elsewhere. No, that's not that one. Let me get the right screen sharing. That one. That's that one. Apologies, should have sorted out my screen share before that. Here we go. That should be it. Hoping that's working. My computer seems to be freaking out a bit. Ah, great. Okay. That seems to be working okay. Right. Okay. Super. So these slides are actually an updated version of some of the ones that I've used previously for a session on how to be a climate conscious coach, but I'm not going to go into the material around that specifically. I'm just going to talk about the science stuff. So as I said, please do ask questions or put questions in the chat. Although the chat's disappeared, I can't see it now, I don't know where it's gone. Anyway, shout out if you've got questions. So I tend to start quite a lot of my talks grounding myself in why I'm here and what brings me to this conversation and what motivates me to do what I do. So I'm sure I'm not unusual for many folk that that's my daughter, her 20-week scan picture. And she still is beautiful, but I can't put a current picture of her on there because she'd just go mad at me. She'd think it was embarrassing. So yeah, my beautiful 16-year-old who's in the background is a large part of why I do what I do, although not all of it. And I'm sure you have your own motivations. And if we had more time and etc., we'd have a conversation about that. But it's good to just take a couple of moments to just breathe in and connect with our motivation for spending time on this work and bringing it to our practice. So, as I said, we're going to focus this conversation in what the science tells us, and less so about what we can do about it, because we're having those conversations elsewhere, and I'm sure those conversations will continue after this webinar. I'm also conscious that some colleagues need to go nearer to than 2:30, so I'm conscious it'd be good to get in as much as possible before 2 o'clock, and then we can perhaps have some questions and conversation before the close. So I'm sure that many of you are familiar with the IPCC report that came out in October 2018, the one that had the kind of strapline that went in the media a lot about we've got 12 years to save the planet. When Antonio Guterres, the UN Secretary General, announced the publication of that report, this is just the first few lines of the speech that he gave. And I'm not going to read it out. You can obviously read that for yourselves. The boldening is my own boldening, so that we face a direct existential threat. And that what we still lack, even after the Paris Agreement, which was supposed to keep us to 2 degrees or less, we still lack the ambition to do what's needed, and we lack that ambition at every level, global, national, international, political, corporate, individual, community. It's lacked at so many levels, unfortunately. I have to say, it also saddens me that some of the most pointed language of this communication, including the direct existential threat, was excluded by most of the mainstream media, certainly in the UK. So it's just part of the fact that, you know, these messages are not getting through to people, which is part of the reason that we're not getting the change that we need. So we're obviously well over a year ahead of this. So You may be, you may be familiar with the IPCC. If not, it's the Intergovernmental Panel on Climate Change, which is a part of the United Nations, or a body of the United Nations, formed just over 30 years ago. And this report, they publish reports on a periodic basis. They basically take, they publish consensus documents. So they take the existing published science, and they review it, and they create consensus involving scientists globally, panels of scientists, and then ultimately the final documents need to be signed off by the politicians in all of the respective countries. So it's a consensus process, and it's also to some degree politically acceptable. So that does unfortunately mean that it's, whilst it is the single global consensus we have, it tends to be behind the curve by 3 or 4 years in the research. That's because there's a time lag between doing the research and publishing the research, sorry. And because it's a consensus-based process, it tends to be extra conservative with a small c as well. And then with a political sign-off means they take the scariest stuff out of it. So with all of those caveats, it's still the best global consensus on the science that we have. And you'll see here that back in 2018, the IPCC was saying that we have to have rapid global transformation to reduce emissions by 45% by 2030 and get to net zero globally by 2050. That's based on what they were saying then, and I'll come back to a little bit more about that. As you can see in the screen grabs on the bottom half of this slide, we're a long, long way from anything like that. We're doing pretty darn poorly, and as you can see on the bottom left there, year on year, each year is beating records for levels of emissions. So I got the latest data on CO2 levels in the atmosphere. There's this is called the Keeling Curve, or at least the steep latter bit's called the Keeling Curve. It's measured at Mauna Loa in Hawaii. It was started in the 1950s by, I think, someone called Professor Keeling, and it's measured there because it takes the it's a very consistent and unbiased measure, in the sense that it's not influenced by factories or pollution locally. You know, it's on an island in Hawaii. You can see that on the left-hand side, many of you may be familiar with this, but I'm not going to make assumptions because it's helpful for us all to start from the same place. That this is time along the bottom, date along the bottom, so going back to 1700, so kind of pre-industrial revolution. Carbon dioxide parts per million in the atmosphere was sort of pretty stable at kind of 280 parts per million. And then you can see as the industrialization starts to kick in early 1800s and beyond, it creeps up, and then exponential increase from the early 1900s onwards, and getting faster and faster. And on the right hand side, you can see that is basically a chart since the Mauna Loa Observatory started measuring. They measure daily. So the latest daily reading was from just literally 3 days ago, and that's what the parts per million measurement is from 3 days ago. And you can see this little zigzag going on here. I've got a health service background, so I kind of think of that almost like a readout, a patient readout. So it's showing me two things. The fact that it's zigzagging is, I metaphorically think of it as the earth breathing, because it's actually the seasons. The earth breathes in carbon dioxide, or at least seasonally, particularly in the northern hemisphere, the trees and other greenery breathe in the carbon dioxide in the spring and summer, and they breathe it back out in the autumn and the winter. So that's what the zigzag is. But obviously Mother Earth isn't well, because her temperature is, her carbon dioxide levels are going up and up. So she's telling us something. Just as an addition on this, scientists consider that a safe level is up to or below 350 parts per million. And you'll see if you read along this graph that we passed that in the 1980s when I was a teenager. So we're not in a good place. You may have seen a number of charts like this. This is an update from Climate Action Tracker. It's a brilliant website. Really recommend their stuff. They are well respected and present really clear diagrams that are based on acknowledged data, etc. So what this is, basically countries as part of the Paris Agreement, etc., have to make pledges and have policies So these pledges and policies are analysed in the sense of, if they were enacted, what would that lead us to in a warming situation? So that's what this chart is showing. So up the side, you've got the level of greenhouse gas emissions on the left, and then years along the bottom. So you can see where we are now, 2020, and the different trajectories. So actually business as usual, which is the grey segment at the top, unfortunately, business as usual is taking us to between 4.1 and 4.8 degrees average global heating. And what we mean by average global heating is the surface, land and sea surface temperature averaged across the globe. So it's a very conglomerate sort of measure. It is what it says. It's an average measure, so it hides huge variations, but we'll come on to that. So we've currently warmed the Earth by 1.1 degrees, and I'm sure you're aware that we're seeing a lot of impacts from that already, which we'll come on to. But actually, this is a trajectory that we're being taken to by the corporations and governments at the moment, and consumers, of course, but that's part of the picture. And you can see that optimistic policies, current policies and optimistic policies, are taking us somewhere between 2.8 and 3.2 degrees centigrade. I don't know if you've heard of a climate scientist called Professor Kevin Anderson. He's at the Tyndall Centre, which is one of the leading climate science centres in the UK. And he's on record talking about the fact that human civilization and any organised society or economy is pretty much out of the question at 4 degrees, if not way before that. So that's where we're heading at the moment. And the 2018 IPCC report, which you saw a little bit about earlier, said that to avoid catastrophic impacts on human society and modern civilization, we need to stay well below 2 degrees, ideally 1.5 degrees. And you can see that actually we are nowhere near on that track. Just apologies if this is a bit tidgy, the text, but I'll explain it. This is a really recent graph from a very good McKinsey article, of all people, that I found only today, which is why I wanted to insert it. So it looks complicated, but I'll explain it. I wanted to include it because one of the questions people have about the climate science is in relation to the fact that it's really hard to get your head around what these small numbers mean. We talk about temperature increases like 1 degree, 2 degree, 3 degrees, and it's really hard to understand for most lay people what is that about, and because actually if you live in a not particularly warm country, or you like warm weather, you like to go on holiday and be in the sunshine, 2 or 3 degrees warmer just sounds nice. And this is why some people don't understand it, and it's totally reasonable because no one's had it properly explained to them, really. So this diagram hopefully helps to explain that. So what this is showing is the shift in summer temperatures in the Northern Hemisphere. So that's where obviously some of us on this call are in, but not all of us. There are similar but different figures for the Southern Hemisphere. So it's about frequency of observations on the side, so the number of days in which that temperature is seen, and along the bottom you've got average summer temperatures, so deviation from the average summer temperatures. And if we start, the lightest colour is the 20-year period from 1921 to 1940. So to make this human, what I think of there is my mum. So my mum was born in 1930. She's no longer 1935. Sorry, she's no longer with us. But bless her, she would have experienced summers like kids now won't even recognise. The summers that our parents experienced in the 30s, 40s, 50s, perhaps, are gone really. And the Northern Hemisphere average summer temperatures, you can see in the recent years, 2011 to 2015, are this darkest distribution. And what's happening is that the extremes are getting more extreme and the spread is getting wider, so that you can see the average summer temperatures in that rectangle, a grey rectangle on the right hand side, is unusually hot summers, where there are 2 standard deviations beyond the average temperature, and then you've got extremely hot summers. Now, I'm apologising that I don't have the actual specific temperatures on those, but it is showing you that the extremes of heat are getting more and more, and the frequency of those extremes of heat are getting more and more. And that, of course, has implications for human health, human productivity, business function, finance, economics, but to my heart, way more important, ecosystems. You know, if humans can't survive comfortably in some of these temperatures, then plants, animals, and ecosystems can't either. And of course, without them, we are nothing. You'll also notice that the tail on the left-hand side is increasingly tiny, so that there just aren't really cool summers anymore. You know, that our kids just know a completely different world, and we've left behind the world that our parents grew up in, and even the world that we've grew up in. It's gone. And this is quite a bit technical as well, but I wanted to put it on because, again, it's really interesting latest data, again, from the same McKinsey document or report, about a range of, to help people understand both physical and socio-economic impacts, and how, excuse me, how really the notion of nonlinear change. So this idea, once we've got our head around the fact that these small numbers sound small, but they're actually massive and really important, nonlinear change is all across, you know, natural systems, isn't it? I'm sure we know that in our kind of systemic practice as well. So this top left chart, for example, we've got what we call wet bulb temperature. I don't know if anyone's come across that before, but when you've got very humid or total humidity combined with a temperature of above 35 degrees C or above, basically humans can't survive because our bodies cannot cool down. You can see that very quickly, this level of, this is a labour capacity, so the ability of humans to function when you get near that wet bulb temperature, and you can see it's non-linear past a certain temperature. So, and this is not a kind of a theoretical thing, because there are increasingly parts of the world that are increasingly getting severe heat waves where this stuff will be coming to pass if it isn't already. Their deadly heat waves have already started. And you can see the other reactions, you know, that these are all non-linear impacts. The other one I'd point to is the one around food, the ability to grow food, so the impact of temperature on crop yields. So some people might, you know, say, oh, this increasing warming is good, you get more, you can grow more crops, da 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 da. To a point with some crops in some parts of the world, but these are not linear, and they're also very complex systems. So you can see here that this is corn crop yield, for one example. Yield goes up, and then past a certain point exponentially goes down. It's just how natural systems work. So I hope I'm not blinding you with too much stuff here. There is a lot of content to just kind of walk amongst. And so coming back to actually what's really happening kind of politically and corporately and in the fossil fuel world, well, unfortunately, it's not good. You're probably aware that global emissions are still rising, and they're rising at a significant rate. As the chart on the left says, the middle one shows that fossil fuel use is growing. It's growing really fast, and it's well outstripping any rises in renewables. So renewables are growing, but really slowly by comparison. And unfortunately, the growth in renewables is being completely swamped by the growth in fossil fuels. Okay, so I hope, you know, many of us are brought up to think that our governments are taking care of us and doing the right thing. Unfortunately, this is one of the charts that makes me committed to activism, really, because you can see that almost all the world's governments are failing their population and their citizens in terms of what they're doing. So this data, again, is from Climate Action Tracker. It's all publicly available. It's based on what countries and governments are declaring they're doing, or their policies to do in relation to Paris Agreement, etc. So you can see the temperature indicators, that what it's saying is basically country by country or area by area, if those policies are enacted, that would lead to a world in which the emissions were such that it would take us to that level of warming. So you can see the whole of the EU, the UK isn't split out, it's just in the EU, ironically, in this. But the EU is taking us to a world which is up to 3 degrees warmer, for example. So you can see there are literally 2 countries that are Paris compatible. It's also interesting that some people like to, some conversations which I you know, would not support, of course, but blame certain other countries. And for example, you can see that India here is doing considerably better in terms of its predictions, etc., than a number of other countries. And then you can see who's where, really. So basically, all of our governments are failing us. That's pretty indisputable. This is saying the same data in a slightly different way, so I won't reiterate that, other than you can see in this nice temperature thermometer, which is one of the ways that Climate Action Tracker present their data. Again, you can just see how actually we'd need to be keeping the world at this safer level of 1.5. What I should say is that actually this, it's not arbitrary, but it's a bit arbitrary that the IPCC has said 1.5, and every fraction of a degree matters. So we're up thereabouts 1.1 now, but 1.2 is worse than 1.1, and 1.6 is worse than 1.5. Every fraction of a degree matters and makes things worse, and gets us nearer tipping points. But I'll come on to that. Okay. So I wanted to just mention this is another area that is quite poorly communicated, and therefore I think are quite often misunderstood. It's the notion of carbon budgets. So I'm absolutely not a climate scientist, and I'm not a carbon budget expert either, but the notion of carbon budgets are also in the IPCC, and it's this idea that you think about a volume of carbon emissions that because carbon dioxide drives heating. I haven't said all of that, I've kind of assumed that knowledge, sorry guys. But because carbon dioxide directly drives atmospheric heating, and scientists have known that for over 100 years or more, the more carbon emissions or other greenhouse gases that are equivalent, the more that we pump out into the atmosphere, the more warming happens. So in order to keep the world at a certain level of warming, that gives us a volume of carbon dioxide and related emissions that we can afford to emit. So that's what a carbon budget is. It's how much more carbon can we afford, in inverted commas, to put into the atmosphere before scientists predict that we'll hit a certain level of global average heating, whether that's 1.5, 2, or whatever. So that's, I've just got a couple of charts to try and sort of explain that. So you can see in this first one that in order to try to keep temperatures at 1.5 degrees in the goal of the climate accord from Paris, then in 2017 we had a budget of 600 gigatons of carbon. Now that's probably hard for any of us to actually imagine what that is. It's a large amount, but it's a budget. It is finite, and that gives us a medium chance of staying under 1.5. I think what they mean by that is either a 50-50 chance. I think it's about a 50-50 chance. So when we talk about carbon budgets, there's a whole load of calculations and assumptions in there, which of course there has to be with any calculation like this. But it is not telling us that if we do that, we know that we'll be in a safer limit. It's giving us a probability of usually 50-50. Now, as a parent, I don't want to put my daughter on a 50-50, heads we win, tails we lose kind of bet, but that is what is happening, or what the assumptions are, unfortunately. And you can see, hopefully, that on this chart, these different coloured lines coming down. So those are the reduction that we need to achieve in carbon emissions from the levels of emissions on the vertical axis over time. And I'm sure if you think back to your maths or physics or whatever at school, if you did any of that, then it's a volume under the curve challenge. And if you had to work out the volume under the curve, so the longer that we take to start reducing our emissions, the bigger the volume under the curve. Whereas the quicker we reduce, the smaller the total amount of carbon we've emitted. So we can't afford to not do this now. And this next picture hopefully sets that similar, but a bit clearer. This chart is related to carbon budgets try to get us to 1.5 degrees with a 66% chance, which is a bit better odds, but it's still not guaranteed. So sadly and frustratingly, you can see on this the box at the bottom right that if we'd started mitigating properly in the year 2000, so 20 years ago, when I was 29 and my daughter wasn't born, we would have had to mitigate at 4% a year. And look at that nice slide we'd have been able to go on. It would have been a nice, you know, a manageable transition at 4% a year. But every year we delayed, and now every week we delay, it makes the drop harder and harder. So you can see they're practically vertical. It means we've literally got no time to do this. So it means, you know, if one, it reminds me of, I think it's Peter, one of my favourite coaching questions of Peter Hawkins, or it might be not Peter's, but I think it is Peter's, about, you know, what is it you're gonna find out in X months or years' time that you already know now? This kind of stuff makes me think of that, because I think, well, you know, I think we know that the world isn't doing what's necessary. And unless there is an almighty breakthrough at COP26 in Glasgow in November, the world still isn't doing what's necessary, because you can just see by the steepness of that, we need enormous immediate action. So I hope that this makes sense, because for me, it's at the heart of one of the reasons why this is such a global emergency. So, and of course, I've just re-included the latest CO2 data just to emphasize that, you know, it's still going up. So when you hear colleagues, or you hear politicians, or you hear corporations or clients or whatever saying, yeah, we're dealing with it, we're on it, we do it, well, yeah, but it's still going up. And until that curve flattens out, nothing's going to change. So I'm afraid there's going to be a few points in this talk that I talk through and say, actually, as if that wasn't bad enough. So as if it wasn't bad enough, there are these things called feedback loops and tipping points. And apologies if some of you already know about this. But you know, see, the Earth is a complex natural system, or a system of interconnected systems in itself. It's like a giant organism, isn't it? And within the Earth systems, there are, you know, over history, there's been ways that the Earth has had ways of kind of coming to its own balance. But we're tipping these things out of balance. So if I take the, on the left-hand side, the reducing ice, I'm sure everyone's aware that the polar ice, both at the Arctic and the Antarctic, is melting very, very rapidly. It's been melting for quite a while now, but it's melting increasingly rapidly. And there's something called the albedo effect, which is basically, analogously, like when you wear a white t-shirt on a hot sunny day, you don't get as hot as when you wear a dark t-shirt. So the white ice at the North Pole, for example, and the South Pole is like the Earth's white t-shirt. It reflects some of the sun's rays and energy back out to space and helps to keep the Earth's atmosphere a bit cooler. But because of emissions increasing average global atmospheric temperature, and sea temperature as well, that's been increasingly melting the ice. So the size of the ice is diminishing, and therefore there's more dark sea surface exposed, and dark surfaces absorb more heat. So the sea absorbs more heat, which in turn melt more ice, and that increases the dark sea. So it's, you can hear that is a feedback loop. There are a number of other feedback loops. Just one other one to highlight is about permafrost and methane release. So permafrost might sound a technical word, but all it is are the bits of the planet that are frozen. So that's land and water, land in the Arctic and surrounding areas that are frozen. And when organic matter is trapped in the earth, normally it would degrade and rot and stuff in the normal way. But when it's trapped in ice, that kind of freezes the degrading and rotting process, and the methane from that doesn't escape. But when the ice melts, as it is doing, it releases the methane. Now, one of the issues with that is that methane is a really powerful greenhouse gas. It's much more powerful than CO2, than carbon dioxide. It doesn't last as long. So carbon dioxide lasts for centuries, if not longer, but methane doesn't last so long, but it has a much more powerful short-term boost hit effect on the temperature. and there are large, very significant large amounts of methane trapped in the permafrost and in the frozen lakes in the Arctic. And that is starting to be released. I mean, you can see on YouTube videos of scientists lighting plumes of methane that's now bubbling up from what were completely frozen lakes. So you can imagine that the more methane is released, the more heating, the more melting, the more methane. So that's again a feedback loop. And the increasing concern of scientists is that there is this thing that the feedback loops, of which there are a number of systems around the world, that reach tipping points. And there was a paper published in 2018 by some scientists talking about what they called the Hothouse Earth scenario, where they described the potential impacts of, at approximately perhaps 2-degree average global heating. And don't forget, we're at 1.1 already, and we're set to bust 2 degrees in our lifetime, or certainly in our lifetime, if not our children's lifetime, probably our lifetime. That those feedback loops will get to the point that they tip into each other. I imagine it like one of those giant domino record-breaking things where you knock one over and it just knocks the whole picture over, and that these have a domino effect in the Earth and gets to a point where the heating impacts and other impacts, whether it's air circulation in the atmosphere, whether it's thermohaline circulation in the oceans, that those things take on a life of themselves, basically, in terms of the physics and chemistry and biology of them, and that they will no longer be amenable to human action, and the Earth will write its own story, whether we're in it or not. And just to kind of add a little bit more to that, some of you may be aware that there was a paper published in Nature pretty recently, just the end of November last year, where some leading scientists, and obviously you can imagine you don't publish in Nature lightly, you have to be a pretty darn well-known and respected scientist to publish in Nature. So you can see the authors there, and this is a paper raising their concern about the absolute emergency nature of what we're facing now, and that they talk about 5 of the 9 tipping points in the Earth system being active. In other words, scientists can see that there is movement happening in those tipping points in the Earth, and that this paper in Nature, which kind of follows on from the Hothouse Earth paper, says that actually they think they could be tipping points prior to 2 degrees, because these are really complex global systems. Predicting exactly where the tipping points are is obviously incredibly complex and may never be possible, but the fact that they're pretty darn sure that there are tipping points and that they're going to cascade into each other is really, really important. This looks like a horribly complex graph. I will explain it. The reason for talking about this one is because it answers the question or the point that sometimes people make about, well, I don't really believe in all of this climate change stuff because the climate's always been changing. I'm not expecting you necessarily to think that. If you do, okay, we can talk about it. This chart is temperature on the axes. On the left axis, it's temperature of the planet of the Earth compared with sort of modern times, i.e. 1960 to 1990 average. And what you can see if you read across the bottom is that it's not a linear scale, and it's like that for a reason. So if we're starting from the left, the scale is in hundreds of millions of years, tens of millions of years, millions of years, hundreds of thousands of years, and then thousands of years. So it's a non-linear scale. It's more like a log scale, if that means anything to you, but don't worry if it doesn't. But basically it's saying, yes, of course, the climate has varied across the planet since hundreds of millions of years ago, but it's done that, one, over huge timescales, and nothing like as quickly as we're doing it now. We're doing it orders of magnitude faster than nature's done it before. And also, actually humans didn't exist when all of these big dramatic changes happened. Modern humans evolved around 300,000 years ago. So you can see those that are in the sort of, obviously near the right-hand side. So that red dotted line shows a +4 degree world, which is where we're currently headed for. And humans have never existed in that world. We haven't had a global temperature like that for 7-8 million years. So we're doing this giant experiment on ourselves, and we've no idea whether we or many other species can survive it. And really importantly, well, one thing I'll just mention, if you go to the far left, the big dramatic peaks, they happened actually a lot slower than that, because you can see that the scale is hundreds of millions of years. So they were actually much more elongated and shallower changes than that. But nonetheless, the peaks in temperature are associated with some of the Earth's mass extinctions that have happened prior to the one that we're causing now. So the peak at 250 million years ago, called the Permian, that was the Permian mass extinction. 97% of all life on Earth was wiped out by that huge temperature rise. But it happened at a rate that was so much slower than we're doing it, so that some species at least could survive. They could either adapt or they could move out the way, because otherwise we wouldn't be here, and neither would all of the life on Earth. We wouldn't be here to be having this conversation, because we wouldn't have been able to evolve. And perhaps in the context of everything I've said on this slide, the most important point to highlight is to highlight that the Holocene on the far right. So the Holocene is the name given by paleontologists, geologists, to the last 12,000 years. And you know, 12,000 years is a very, very short blink of an eye in geological time. But you can see that how stable the temperature and climate has been in the Holocene. So it's this 12,000 years of stability, which has meant predictable, fairly predictable weather patterns and climate patterns globally, that has led to human civilization and population as we know it. So everything that we depend on, know, use in our lives, from our iPhones to our coffee, to our clothes, to our supermarkets, to our cars, to our homes, everything that we know has depended on this stability for the last 12,000 years. Because without that, we wouldn't have had agriculture, and we wouldn't therefore have had larger settlements and economies, etc., etc. And you can see you may be able to see right at the very far right of that chart, there's a sudden uptick, and that's the temperature increase that we're driving. So we are taking ourselves, kind of knowingly now, we are knowingly taking ourselves out of the Holocene and into what's called the Anthropocene, which is a whole new geological and paleontological time scale and zone. And we're taking ourselves out of the stability that has led us to be where we are now. Okay, and conscious I'm chucking loads of charts at you, and I'm really happy to answer any questions about them either within this conversation or follow-ups. And I also probably need to speed up shortly, which I will do. This chart is from an organisation called Carbon Brief, which is also a really good website. Again, really clear and reliable data, etc. And this is from a video. You can see the link there, but I thought showing a video would be too complicated, so I've just screenshotted it. And what this is really saying is about cumulative emissions, because, for example, some arguments or points are made about, well, the UK, for example, is only a small emitter relatively in the world, so we don't need to take much responsibility. It's actually really China, India, US, or whatever that need to take the most responsibility. And well, it doesn't really work like that, because the Earth acknowledges and works on or responds to the total level of cumulative emissions, not what we're just emitting now. Both are important, but it's the cumulative emissions that have done the damage and are still doing the damage. So you can see on the left, in 1850, the UK was by far the biggest emitter, because we started the Industrial Revolution in the UK, so that's why. And these other countries were hardly anyone was emitting anything. And then you dial forward to 2018, and yes, the USA is the biggest emitter, China, Soviet Union, Germany, but actually we are not, in the UK, from a UK-centric point of view, the UK is not a tiny emitter, with the 5th biggest emitter globally. That doesn't detract from where other countries are, but actually you can see when you look at it cumulatively, it's a different picture. Just as it is for the USA. The USA wasn't emitting much, but obviously is the world's largest cumulative emitter at the moment. Okay, so enough of the charts and the data for the moment, guys. I'm conscious I've chucked a lot at you, but I do hope that made sense. I just want to come on to a few rapid sort of highlighting of So if that's the science, what's it doing? What impact is it having right now? Because none of that is theoretical and detached from reality. It's all impacting on human and non-human life right now. And hopefully you guys are increasingly aware of this, because the media coverage has improved and increased a lot in some places, at least over the last year, but there's still some way to go. So it's the climate crisis or climate breakdown. I prefer to call it climate breakdown, because you can see what we've talked about so far. We are completely breaking down the normal Earth's weather patterns and weather systems. So we're getting heat waves, so deadly heat waves in some parts of the world, like India and Pakistan, at temperatures that humans and other animals literally struggle to survive. Mozambique last year had Hurricane Idai, and there's been many other disasters like that since. If we think about, well, many parts of the world, to be honest, it's almost too hard to list them, but just some examples here. And at a very human level, really how gruesome that gets really quite quickly when we're talking about people getting hungry and fighting over food. I'm quite food and farming and soil based because I love growing things, so I always highlight a lot about food. But for US colleagues, I'm sure you're aware that the Midwest has been devastated by floods and cyclone bombs and various extreme weather, and those extreme rainfall and floods has caused farmers in the Midwest a lot of problems with either being able to plant crops or harvest them, and that's leading to economic issues, societal issues, community issues, mental health issues, increases in suicide rates, all sorts of stuff. But if we think about the Midwest as being one of our bread baskets in the world, that's an indicator of what's to come, really. New Zealand, gosh, this is a screen grab from last year. Obviously, we've had more horrific fires since. Again, that's from Queensland, Australia, this time last year, when they had drought followed by flooding, killing 500,000 cattle. But as we know, everything has really dialed up to a horrific scale in terms of the fires, etc. since. Canada isn't not affected by this stuff. Canada, everywhere in the world gets hit, basically. And I just compiled some images from the latest Australian bushfires situation, whether that's the scale of the fires. Some of you may have seen some of this, but the Australian fires have spread to an area that is as big as England and Wales, pretty much put together. It's difficult to imagine, or if you're in the US, you can see across New York, Greater New York and beyond, or most of Japan, that the scale is beyond comprehension. I find it beyond comprehension, and the ecosystem, animal and human costs are large and increasing. And at a global level, the Australian fires have been so enormous that the smoke plumes are going right around the Earth. And Europe and other areas are, of course, not escaping this. In the last year, we've had heat wave after heat wave and record after record broken in 2018 and again in 2019. People sometimes think, yay, London will be like Barcelona, but unfortunately that's really irresponsible media reporting, because it's not as simple as that. An example from Central Asia becoming increasingly able to grow crops. Well, I think there's, I think Ali, you might need to go on mute. I think we can hear some background noise, if that's all right.
Oh, sorry. I thought I was on mute.
Don't worry, not a problem. Thank you. And then another example from South Asia. So there are so many. One has to look for this stuff because it's not necessarily widely publicized and talked about in mainstream media, unfortunately. But if you look, there are impacts happening in every continent and every area across the planet. Apologies for non-UK based people, this is a bit UK centric, but just coming back to some very local things, and there'll be the equivalent of these for any country that you are in. There are whole villages in the coastal areas of the UK that are going to be decommissioned. This is an example from, excuse me, from Wales. A whole village is going to be decommissioned. The wildfire levels in the UK have increased significantly, admittedly nothing like other areas of the world, but for here it's been major. We've had thousands of people evacuated from a town because a dam was going to burst, and we've had lots of flooding and crop failures and agricultural issues in this country, but none at the level of the global south, for example. But it's still happening here. Nowhere is immune to it. I just wanted to put this slide up just to flag a bit about adaptation, because adaptation is an area that's just hardly talked about. As I think I've alluded to, but I will just sort of touch on, because of the sheer global physics, there is what's called a time lag, or a thermal lag in the heating impact. So even if we stopped all emissions today, if only we could wave a magic wand and do that, but even if we did that, there is the physics of the global system means that everything that we've already emitted into the atmosphere will keep on driving warming, because there is a thermal lag, and that thermal lag is between a decade and several decades or beyond. So we know that for at least a decade, and probably a number of decades, even if we stopped everything today, the planet will keep warming. I metaphorically think of it more as a supertanker, because it makes it easier to understand. If you put the brakes on a supertanker, it doesn't stop straight away. It's a huge, slow-moving thing, and it takes a long time to stop. Its braking distance is a long thing. So that's the same. Why I mention that here is because we need to when we get our heads around this, and it isn't a single process, it's a long process. We need to sit with this and live with it and get our heads and hearts around it. But there's a lot of mitigation to do, which is reducing emissions in a whole load of ways, and protecting our ecology. And at the same time, there's a lot of adaptation to do, because we need to adapt to what's coming. And a lot of what's coming is going to happen whatever, because of this thermal lag, and because of other natural processes that are in train now that are going to keep going regardless of what we do. So we have to have a really long-term perspective, and one way of looking at it from our personal point of view and our climate point of view is this is the single biggest leadership challenge that humanity has ever faced. We need stories, we need narratives, and we need action that work over decades, and we need to keep focused on this for decades. And humans have never done that before, because we're wired to look at short-term threats that are right in front of our nose. But we have to, enough of us have to understand the real long-term, slow but massive, and increasingly not slow, impact of this, because that has to drive our awareness and our action. And so I raise this because there is increasing work going on adaptation, but it's not talked about enough, and there's an awful lot that we have to do, because things will happen regardless of what we do on mitigation. And I'm afraid this is another "if that wasn't bad enough" moment. So if that's a lot of the climate science in a nutshell, and this is from the ecological science. So, the damage that humans and human society is doing to the web of life, the plants, animals, and microorganisms that support the web of life, including ourselves, which we forget we're part of. So on the left, the screenshot on the left is from another United Nations report, came out May last year, and it's from a body called the IPBES, which is the Intergovernmental Panel on Biodiversity and Ecosystem Services, which is a right mouthful, but another huge scientific consensus document, probably 1,000 pages or more, I think. And they published with the headline of 1 million species at risk of extinction in our lifetime. So that came out last May, and I'm sure many of you are aware of the damage to, for example, coral reefs, the Amazon, but also pretty much every habitat is in danger from either deforestation, agriculture, pollution, climate, human population, or a combination of all of those and more besides. And of course, we don't just threaten nature with this, we are nature, so we threaten ourselves. You may have heard this figure before, that if we think 10,000 years ago, before humans did much kind of civilization-y stuff to the world, most mammals and biomass on the planet were wild animals. We were a small number, and everything else was wild. And how incredible it must have been. But unfortunately now, and much of this has happened in our lifetimes, much of the acceleration of this devastation and basically annihilation of nature has happened since the 1970s, and I was born in 1970, so it makes me feel particularly grim. If we think about the Noah's Ark story, or the stories that we might read to our children or grandchildren about the animals that went in 2 by 2, well, unfortunately, most of those animals don't exist or are functionally extinct, i.e. they're in populations that are too small, or habitats that are under threat, or niches that are not viable. and most animals on the planet are the ones that humans breed for food. And most of the rest of the mammals on the planet are us. And then there's 4% are wild mammals. So it's pretty shocking data when you really engage your head and your heart. A little bit on the oceans, because we forget about the oceans and we do that at our peril. So actually I'll come to the next one first. So the oceans obviously cover 7/10 of the Earth's surface, and they're mega important for lots of reasons. The oceans are a carbon sink, so just as trees on land soak up a lot of carbon, whether the plants do, the kelp forests and other plants in the ocean soak up carbon. The creatures in the ocean soak up carbon because all organic life is built from carbon, fundamentally. And the phytoplankton, which are the little tiny microscopic plants in the upper oceans of the upper layers of the ocean, also absorb a lot of carbon. But unfortunately, well over 90% of all the excess heat that we've caused to be knocked into the Earth's atmosphere has been absorbed by the ocean. That's what that chart's saying. I wouldn't worry too much about the detail because it's really technical. But basically, it's saying that the ocean heat has massively increased at an almost unimaginable level, like Hiroshima bombs equivalent of energy going off every second in the ocean. It's unimaginable. And if it wasn't for the ocean absorbing all that heat, we would already be gone. So they've done us an incredible service, but what that's meant is the oceans have warmed, and warmer oceans release oxygen. They can't hold as much oxygen, so there are areas in the oceans that are becoming dead zones. There are large areas of ocean around the planet becoming dead zones where the oxygen levels are such that they can't support much life or any life. Species are having to move north to cooler climes to be able to breathe. So cod is migrating northwards in the ocean towards the Arctic to be able to breathe. The acidity in the ocean, so ocean has also absorbed quite a lot of carbon dioxide. That drives the acidity levels up. So that means that also harms certain ocean life, damages phytoplankton and crustacea, so animals with shells are struggling to build their shells. And also the ocean warming causes thermal expansion, so that causes sea level rise, as well as the melting of the north and south ice caps. And just to come back to this slide, pollution from everything from sunscreen to runoff from agriculture and more besides is harming the phytoplankton in the ocean. So this is an amazing group of scientists in the Global Oceanic Environmental Survey. I think they're all volunteers, they're amazing. But I just put this slide in because it talks about how the phytoplankton levels are reducing 1% year on year in the last 20 years. And phytoplankton are responsible for a significant part of the oxygen that we breathe, but we're killing them off. And things like toothpaste, makeup, sunscreen are full of chemicals that harm phytoplankton, but no one talks about it. So, oceans, a little bit more on ecosystems. So, I'm sure many people are familiar with the damage that habitat destruction, but also really importantly, agricultural chemicals, weed killers, pesticides, etc., is damaging soil and also damaging insect populations, including pollinators. And this is often done with the agreement and support of subsidies from politicians or lack of regulation of corporations and so on. There are lots of examples of this. You know, without insects, particularly pollinators, support a significant part of the food crops for the human population. So without pollinators, we have a difficult future, if any future. And you may be aware that in parts of the world, for example, in parts of China, I think humans are now being paid to hand pollinate because there's no pollinators left. Also, the way that we farm, the monoculture, the huge swathes of single crops and the farming practices are very, very damaging. Obviously, I'm sure you know about deforestation in the Amazon and elsewhere. So land use is dreadful because we use 6 to 8 times as much land to grow crops to feed animals, to then eat the animal products rather than just eat the plant products ourselves. So on a land use and biodiversity and nature harming level, that's really bad. it's also bad because naturally healthy soils and ecosystems are carbon sinks, so they lock up carbon. But when you damage soils from modern agriculture, the carbon in the soil is released. That's because we harm the quality of the soil, we dig it when we shouldn't be digging it, we damage the biome in the soil with the chemicals, and all of that releases carbon and reduces the quality of the soil, such that we have a limited number of harvests left in our soil fertility in many parts of the world. Which is a huge issue. I don't want to dwell on human population, but I'm sure everyone knows that human population is still increasing and is not forecast to sort of level out till about 2050. I could do a whole conversation about human population. I won't do that, but it is important to kind of have that in one's mind, because as more people expect a middle-class lifestyle with a lot of meat and dairy, that drives up deforestation, damage to habitat, modern mass agricultural farming practices, etc., because that's the way that the system runs. It doesn't have to be like that, but that's the way the system works. And there is evidence already from, this is a screen grab with some research, that climate change is affecting crop yields. There are some at the moment, there are some winners and losers. If you look at that data, I'm happy to share any of the references or any of the articles from this. There are some winners and losers. So yes, some crops in some parts of the world increase, but the trend is downwards. So I understand from this research behind this article that there's a 1% reduction year on year at the moment in global crop yields. And there's a fairly small number of core crops. I think it's 9 or 10 core crops like maize, rice, soya, wheat, etc., that most of the world population gets its bulk calories from. So, and whereas up till fairly recently, the gross numbers globally of people who were in food insecurity and risk of starvation, that was decreasing globally, and in the last few years it started to go up again. So there's hundreds of millions of people who are in food insecurity and risk of malnutrition and starvation. And, it's not a pretty picture. So I'm going to pause there. I think I'm just going to say two or three more things, and then I'll stop and we can cover questions. Just a little bit of context, really. This is not so much the science, but you could argue it's the social and economic science, that we need to remember that, whilst, yes, the human population is large and increasing, everyone, different people in different parts of the world, largely depending on their wealth, have different emissions. So this is a global picture, world population based by income decile. So the richest 10% globally, and that means people with a total capital of more than something like $75,000, I think. I need to double check that figure, but it's not a massive number. So it's not a huge number, puts us in the top 10%. So the top 10% globally are responsible for half of all emissions, whereas the bottom 50% of the wealth decile globally, obviously most of those people, if not all of them, will be in the global south, are responsible for 10% or less of global emissions. So this is a really important part of the picture. Okay, I think I am going to, I'm going to stop there because there's more I could cover, but I want to leave some time for questions. And we've kind of effectively covered the essential overview of the snapshot of climate and ecology. So I hope I haven't thrown too much information at you, and I'm really happy to answer any questions. Does anyone have any questions? I can't see the chat, unfortunately, for some reason. I don't know why, but if anyone would like to ask anything, feel free. I'm conscious that I've thrown a lot of data at you. I'm conscious that you may have a whole whooshing around of thoughts and feelings going on, and that's all completely normal.
Sorry, I just wanted to say a huge thank you. I'm on a train now, so it's very busy. That is a massive summary of the research. And I guess there's a question that's in my head, and I have my own answer to it. But what is the value of individual action, and what can we do to support systemic action?
Thank you, Alison. I really appreciate your question, and thank you so much for staying with us even when you're on the train. I do really, really appreciate that. What is the value? So I heard your question was, what is the value of individual action, and what can we really do to make a difference? And that's it's a great question, and it's a really important question, and it's one that I personally wrestled with a lot in 2018. Well, I've wrestled with it on and off most of my adult life, to be honest, but I wrestled with it a lot in 2018 in relation to a number of things that happened in my life, and also the real dawning that hit me from the 2018 IPCC report, where I really realised that governments and corporations around the world are not doing what's necessary. So coming back to your question, I think personally I went through the process of kind of analysing my life and thinking about what are all the communities, sectors, bodies, audiences that I'm part of, and where can I impact on all of those communities, and in a way that is bigger than me just changing my personal lifestyle. Because I've done most of that. There's bits more I can do, but I've done most of it, and I can't get my personal footprint down much more than it is. We are doing more, and there is a bit more we can do, but I've done most of the obvious things and beyond. So beyond our personal footprint, there is an awful lot we can do. And to be honest, that we're having this conversation in part because of that thought process I went through a year ago, thinking, right, I'm a coach, I can influence the coaching community. That was one of my thoughts. So I think we all have communities that we're part of. As coaches, we have conversations with lots of people who know lots of people. We have conversations with lots of significant leaders in leadership situations. There's quite a bit of background noise coming from somewhere. I don't know where it's coming from, but anyway, I'll keep going. So I think if we think about our life and think about every aspect of our life, our professional life, our political life, our community life, etc., our business life, we can have almost as much impact as we want to in all of those circles. We just have to set an aspiration and go for it, really. And all those actions I would count as activism. So I don't mean, obviously I am a climate activist, and I totally believe that climate activism is an utterly fundamental part of what we need to do. It's not the only part. We need activism, and we need other forms of action, and activism comes in many forms. So in a way, I consider this conversation as a form of activism. So we can be as active as we like, but I think there's a climate scientist you may have heard of in the States called Peter Kalmus, and he's done lots of things. And one of his straplines at the moment is, we need 1 billion climate activists. We do need 1 billion climate activists. We need people to be active in every walk of life. And one of the biggest things we can do is talk about this, raise our own awareness, educate ourselves, and talk about this in every walk of life. But without going into it now, this is kind of one of the reasons I developed my climate conscious coach model, and wanted to I put that together first off for myself to help me think through what I could do, but then also to share with others, and having a parallel model for leaders and for citizens to be able to give people a thinking framework about, actually, you can do this too. Yes, there are some folk, of course, who are literally trying to put bread on the table and can't think beyond tomorrow, and I get that. And there are swathes of us who can think beyond tomorrow. And the more that we can think beyond tomorrow, the more responsibility we've got to act, because we have that opportunity. Okay, I'll pause.
Beautifully put. Thank you.
Thank you, Ali. Thank you for staying with us, given you're travelling. Any other questions on the science, or the so what, or making sense of it, or challenging any of it? And really open to any.
Hi, it's Viv. Hello. A few points linking to the question that was asked to you, and that is 2 things that you have posted on LinkedIn. Well, first of all, thank you so much for the presentation. It was very, very clear. It's got information in there that I didn't know, a lot of information I didn't know. I'm really glad there's a recording that I can then share with other people. And first question is, can we have references
Okay.
for the research? Because I was talking to somebody a few weeks ago, and I could tell that they would be very much wanting to see the references to science, otherwise they weren't going to believe it. That wasn't in a coaching context, that was a personal context. So if you've got some of the, like a reference list, that would be really useful. The second thing is, two things that you have posted on LinkedIn, which I found really useful. One was the post about Elizabeth Sawin.
Oh, yes.
Yeah, talking about feedback loops. So I think, as we all know, some people can feel incredibly frightened and disempowered. And I found her blog, or whatever it was, really reassuring that actually small actions can have a knock-on effect. So for everybody to do small actions, even though you maybe aren't in the place where you can take big action, that is reassuring that those may have some sort of impact. So I found that really, really useful.
Yeah, thank you.
And today I found your 10 actions for things you can do personally, which you wrote about 9 months ago. So I've printed that out. I'm going to use that as personal checklist. So thank you for that. So for other people who maybe wanted to find that somewhere on LinkedIn, it was really, really useful.
Oh, thank you.
So yeah, so that's really what I wanted to say. And I am very interested in another context in having discussions with those who want to talk about working with people in business.
Fabulous.
I'd love to do that.
Great. Fabulous. Thank you. And there are, you know, I think the feedback loops in climate sense are very scary, but feedback loops in human systems are opportunities. Definitely.
Yes, absolutely.
And
I love that blog, was so interesting. I just read it and I've printed it out, although it's not worked very well. So I keep reading it because it's got little nuggets to bore in there. That are really
I think it was a Twitter thread, wasn't it? It was a Twitter thread. Yeah, she's definitely worth following on Twitter, Elizabeth.
I'm doing that now.
She's very and I find her work not only really lovely, but also really helpful in a human and a coaching sense, because she's very systemic. She takes a really systems perspective, so that really kind of sits well with me. And I think it's there's something about linking what you said, Viv, and thank you for that, with Ali's question of, I think three things about it. I think that we personally, there isn't much more important for me than making a difference on this stuff, because I sort of I'm a pretty darn rational kind of analytical kind of person, and I kind of do things and think, well, is it more important than that? No. Is it more important? And it's just nothing else comes out higher priority, really. So that leads me to do as much as I can, literally every day, and some of those things are small, and some of those things hopefully are bigger multiplier effect things. And so I guess an expression which I have an allergic reaction to is that, well, we'll just do our little bit, because if we just do our big bit, that's good, because our little bit, in the context of, unfortunately, and I don't blame people for this, because people have not been told the truth by the institutions that run things. So people don't understand the nature of what we've talked about in this last hour and a bit. So people's little bits, whether that's doing a bit of recycling or having meat-free Monday, it's nowhere near enough. And you only have to spend a small amount of time looking at the science to really understand it's nowhere near enough. But actually, if we each do our bit, and we challenge ourselves to make that bit as big as we can make it in our lives, then that's got a big chance of working. So yes, each do our bit, but I personally say, challenge ourselves to say, can we look ourselves in the mirror and say, are we doing the most we can do, or can we do more? Yeah, definitely. And actually, it's almost liberating in a way. Probably also because of my age, that I really don't care what people think very much anymore. But also, it's kind of liberating, because the what's the worst that can happen question. Well, we can see what's happening and what's going to happen, and it's going to get a darn sight worse unless we do a hell of a lot. So it's quite freeing in the sense of taking risks. If let's just take some risks and have some more challenging conversations, because that's a lot easier than facing what's going to happen if we don't. Yeah. Thank you, Bev. I think we've got a minute or two remaining, so a last question, if anyone's got another question. Okay.
Can we share this?
Oh, sorry. I can hear someone's got a question. Was it Ali?
It was me. I was just saying, Viv mentioned sharing this. How can we access this recording and share it? And maybe the CCA is a place to access it. Anyway,
oh, that's a good idea.
I'll shut now because of Vimala wanted to ask.
Okay, thanks, Ali. Good idea. Vimala.
Zoe, all I wanted to say is thanks a million for all this information. Of course, in this part of the world, it's with the coaching community that I'm trying to do some work with, but raising awareness and consciousness is kind of not, it's difficult. I had a conversation, I was at the ICF chapter dinner, so I started talking about what happened in King's Fund, and out of number of people are not connecting it, yeah? They kind of glaze over. So that's my challenge.
Yeah.
But I have teamed up with somebody. The question I want to ask is that, what kind of support or what kind of help? I mean, I'm listening to all that's going on in UK from you, from the group, but what can I do here? How can I start?
Gosh, that's a great question, and I'm more, because I'm conscious of time from now, I'm really happy to have a follow-up conversation to talk about through with you in more depth. But I think that there are people wherever we are, even if we feel like our general field and wider public conversation is not engaging in this, there will be people in your area who are, whether that's activists with a capital A or activists with a small a. And it might be the academics in the climate science in local universities. It might be the young people in certain schools. It might be some parents somewhere. It might be a local Extinction Rebellion group, because there will almost definitely will be one. But actually just connecting, finding out what other communities are awake and are doing things, and then building some community with them, I think is a powerful start, because it's easy to feel really alone, and you're not alone. There's thousands of us trying to act, thousands and thousands of us trying to act. So connecting up with others locally and beyond, and keeping that, using that connection for inspiration and energy, and to keep on ourselves looked after and renewed, because this is a long-term thing that we're going to be working on and working with. But I'd be more than happy to have a separate conversation with you if that would be helpful.
Okay. Thank you for that. Yes, that's a good start. Thanks.
All right, thank you. Thanks, Vimala. I wasn't sure if there was a question from Amy or Nicole. Did I miss one? Hi,
no, I'm just absorbing it all in.
Same, yeah, no questions from me.
Okay, thank you both. I really appreciate you both joining us, and all other colleagues. And I am really aware that I've chucked a lot of information at you. It may have been overload, and be kind to yourself with whatever emotions are coming up for you as you sort of reflect on this, because I do fully, wholeheartedly know it's not easy, and I'm more than happy to have follow-up conversations with anyone. So don't sit there on your own if you just need to talk about it. Okay, thank you so much. Unless there's anything final anyone else would like to say, I'm just going to draw our conversation to a close, except I'm not doing a very good job of doing that. And I will look to put this recording on. Sorry, I need to stop sharing. Where's stop sharing? Right, I will stop recording and work out how to share the video. And there we are, stop sharing, that's what I wanted to do. And I will stop recording and work out how to share it with you guys and beyond. And thank you so much. And do contact me separately if you want to have a separate conversation. All right.
Thank you so much.
Thank you.
Love to everyone. Sorry for the technical faffing about there. Take care.
Take care.
Have a good